Hi students, problem number 7. Prove the following Boolean expressions using the laws and theorems of Boolean algebra. The first subdivision is we have to prove that a plus b multiplied with a plus b complement is equal to a. Similarly, the second and the third subsequently we will go. So first we will start with the left hand side. So always you begin with the left hand side. So this is a plus b. Okay, left hand side is equal to a plus b into a plus b complement. So this is now equal to, first we will multiply this a with the right hand side, the right side bracket, two terms. So a into a is a plus a into b complement plus, next I will multiply with b. So b into a can also be written as a into b. Okay, because b into a is also equal to a into b. We have already studied the commutative law. Okay, plus this b into b complement. Okay, b into b complement. Now this a into a, by the law and the theorem of Boolean expression, this is also equal to a itself. A into a is a only. Plus I will write this term ab first. Okay, ab term first I am writing. Next a into b complement I am writing. I am interchanging these two terms in order. Okay, plus b into b complement is equal to 0. So if you give a value b equal to 0 means b complement will be 1. So 1 into 0 is 0. The other way also it is 0 only. Okay children, now you see a and a is the common factor, is it not? So I will write a as a common factor. So first term is a into 1 plus the second term is a into b and the third term is a into b complement. Okay, so this is now equal to a into 1, because depending on the values of either b or b complement, already it is taking a value 1. So if it is a high state, is it not? So with the high state, if you add 0 or 1, it makes no difference. Already it has attained a high value. Therefore the term 1 plus b complement must be equal to 1 itself. So a into 1 is equal to what? A. So this is equal to the right hand side. Okay, right hand side must be equal to a. So first one we have proved. Okay, second one is a into a complement plus b is equal to ab. We have to show that. So once again we start with the left hand side is equal to a into a complement plus b. So this is equal to, first term is a into a complement. A into a complement plus second term is what? A into b. By the theorem of Boolean algebra, a into a complement must be 0. Is it not? If a is equal to 1 means a complement is 0. So this product will be equal to 0. So 0 plus ab must be equal to what? Ab. So this is equal to the right hand side. It's very directly it can be done. Is it not? So we have proved that the right hand side is equal to ab. Once again, the third one we want to prove a plus b into a plus c is equal to a plus bc. So we start with the left hand side always. So this is equal to a plus b multiplied by a plus c. So once again a will be multiplied with this a plus c. So a into a, first term a into a plus second term is a into c plus the third term is b into a. By commutative law, it is also equal to a into b. So I will write ba is also equal to what? A into b plus the last term is b into c. Once again a into a is by the Boolean algebra, it is also equal to a. Then this AC and AB in the ascending order if I write means first AB term, next AC term I can write, the last term is BC. Now in the first three terms, which is the common factor? A is the common factor. So this is A into 1 plus B plus C plus BC. So what you can guess now, 1 added with low or high will take the value 1 itself. Already it is a high. Therefore this must be equal to what? A into 1 plus remaining term is BC. So this must be equal to A into 1 is A plus B into C is BC. So this is equal to the right hand side. Okay, A plus BC. So all the three identities we have verified. I hope you must have understood well. Fine.